G'day. In this series of videos, we are doing some psychometric modeling. We are starting from scratch and we are slowly building up an in silico model using sampling from the uniform distribution, and we're going to compare it to a Gaussian function. In the last two videos, we've learned how to generate uniform distribution, samples from the uniform distribution, and we've also created the skeleton of our Gaussian model. It's a cumulative distribution function, and remember the CDF cumulative distribution functions are our psychometric functions. And so if you haven't seen those videos, stop this video, have a look at the other ones, and it should bring you up to speed. If you have seen those, welcome back. Good to see you. In this video, we're going to start to create the actual experiment part, the actual sort of the structure that will control, our in silico subject do our experiment. So we're going to run another function, going to create another function, and we're slowly going to build onto that. We've done a lot of preparation up until now. So let's see what we have to do. So we're on video 3 now. So let's perform the experiment where the subject is exposed to 10 different stimulus intensities, say 20 times. Well, let's just say n times. So what do I mean by this? In your actual experiment, let's say you're doing we'll just go back to the volume experiment. So you're going to expose your subject to, say, 10 different intensities of sound from 0 to 10. That corresponds to, the number on your volume dial. We won't go up to 11 because our amplifiers don't go to 11. But your subject can be exposed to either 1, 2, 3, 4, up to 10. And what you want to do is you want to test to see whether or not your subject heard that sound, okay? So you present them a sound at 10, it's really loud, and so they got that correct, okay? And you present them something at 0, it's very soft, it's basically you can't hear it at all, and so they'll get that trial wrong. But instead of just doing from 1 to 10 only once, it's customary to do a number of trials at each stimulus intensity to see what happens, over time, or to increase the number of samples at each stimulus intensity. So that's what we're talking about here, n times. That's the number of times your subject is exposed to that particular stimulus intensity. Okay? So what we're going to do, again, we're just running between 0 and 100. This is just a nice, easy stimulus intensity array. But what we're going to do, if you remember from our previous video, we went between 0 and 100 in steps of 2. You don't want to go 0, 2, 4, 6, 8, 10. That's just going to take you forever. So what we're going to do is we'll just go in steps of 10. So your subject will be exposed to either 0, 10, 20, 30, 40, 50, 60, or whatever. Okay, so we just have to change our model here. So we'll go from 0 to 101 in steps of 10. So that should be fine. And again, it should return, the StimX and the model PR. So if we run this now, we'll just go X. We don't really care about the model PR, right? We're going to run this function, so model PR. We're going to run that function. But since we don't really care about what happens in the X, in this model PR, we just want to plot the X values. What we're going to do is we'll just put an underscore here. Okay, so it's a bit like saying, hey, look, we don't really care about what's going on though. We just want the first value of 2, and then we'll just print X out. So this is a way that we can still return the values, but we don't care what happens with them. So here we go, 0, 10, 20, 30, 40, 50. So this is great. This is going to be our stimulus intensities that we will eventually present to our subject. Can we get away without having that underscore there? So if we just have X, comma, and then nothing. No, you see how it says too many values to unpack, expected 1. So we do need to have just a placeholder to say, hey, look, something's going to go in here, but we're not going to use it later on. Okay. So either way, we have changed our model to now correctly, do it in steps of 10. So now what we need to do is we need to create a function, and we'll call this experiment, because this is where we will run the experiment. And what we're going to do is we're actually going to pass into this function. We're going to give it the number of trials. So remember, we wanted to expose our subject to, say, an intensity of 0 20 times or 30 times or 5 times, and then we wanted to hit each one of those stimulus intensities, a certain number of times. Normally, you won't just go 0, 0, 0, 0, 0, 0, and then 10, 10, 10, 10, 10, and then 20, 20, 20, 20, 20. That's poor planning of your experiment. What you should normally do is interleave those so you don't get any biases or any cumulative effects come through in your experiment. You want to randomly sample, so one trial could be a 90, and then the next trial's a 20, and then another trial's a 30, and then the next trial's an 80, and but over time, each of those stimulus intensities will come up, that certain number of times. For our model here, we're just going to do them all sequentially, but that's a bad thing. Do not do that. We're doing it for sake of simplicity. So we need to give it the number of trials into this array, and we'll also give it the stim x values. Why? Because, well, we've generated them here. We don't need to generate them again. We can just pass the variables from one function into another function. Not a problem at all, and so this is what we're going to do. What we will need to do when we run this experiment is we will need to run the model probability before we run the experiment function. Okay, because this experiment function is going to be waiting for, it depends on these values here, which will only be generated when we run the model PR. Okay, so just to remind ourselves, we will run the stimx. We don't care at this stage what happens to the model PR, and so we'll go, so the model PR values, the Y values, we don't care about them just yet. We will in the future, but not just now. So there we go. So we do have to run that first, and then we will have to run our experiment function. Okay. So we're just planning ahead a little bit. So we've got our function here, stim underscore x, comma. So we've got a thing there. Okay. So we can just pass there, and then that should get rid of that error there. So if we don't want to do anything in our functions, we've just got it as a placeholder to remind us to do something later on. You can just put a pass. Okay. Or you can just return null. Return none or something like that, and that's totally valid. It's going to return nothing. But anyway, we want to indent in, run our doc string, and so this is going to be the workhorse. This is the main function that's going to do a lot of the modeling for us, a lot of the trial by trial stuff. So what do we want to do? We want to perform our experiment here. We want to do, say, a method of constant stimuli. We're not going to do method of limits or a staircase method. Okay, so it's going to be a MOCS, and it's not going to be randomized, not randomized. So a method of constant stimuli just means that for our experiment, every single one of our stimulus intensities is going to be hit the same number of times. It's a constant stimuli method. We're not doing any staircase method or adaptive methods or method of limits. It's just, hey, everything's going to come up a certain number of times. And so we want to give it each stimulus intensity, and that's going to be our stimx. It will be run number of trials, so n times, and so that's our number of trials. Okay, so what we need to do, what we should do at the start, is just generate some containers, some empty containers into which we will put in essentially the number correct, or each trial that stimulus intensity has come up, we'll put into it whether or not that subject got it correct or incorrect. So let's just create some empty arrays, some empty containers here. So let's have a go. So we'll just call this say response. So subject response array equals, okay, so we want to create arrays. So the way that we can do that is we can say we want to create array for stim in stim x. So what's this going to do is this is going to create an array of elements where each element in that array, okay, is going to be itself an array, and it's going to return an empty array for every single element, okay, in this array here. So if we print out, okay, the length of stim x, okay, and then we print out the length of the subject response array, okay, they should be exactly the same. Okay, so our StimX should have, I think, 10. We're going to hit 10 stimulus intensities. Okay, what have I done wrong here? Okay. We'll get to the error. So what we're doing is we're going to get 10 different stimulus intensities. That's what we want to run at. And so when we create this set of containers or empty arrays, we should have 10 different empty arrays where each of those empty arrays will eventually correspond to 0, and then the next one 10, and then the next one 20, and then the next one 30. Okay. Now, what does this error mean? Experiment 2, so this function is missing 2 required positional arguments, number of trials and stimX. So this error means that, you see how we've got these 2 things here? These are arguments that we have to pass into the array. When we, into the function. When we called the function, okay, we didn't give it anything. So it's like, you want me to use 2, but you've given me nothing? WTF, ruffle. And so what we should need to do now is we need to give it these 2 arguments. And so the first argument is going to be number of trials. We haven't set that yet. We will. And we need to give it, oh, I just accidentally clicked the touchpad. And we need to give it stim X. And remember, this stim X is going to be returned from our model PR function because we only want to generate it once, okay? So our number of trials, equals, say, 10. We're not using this yet. We will use it in a little bit, but we're setting it up for later. So here, we'll just instantiate some variables here, or just create some variables that we'll use later on, okay? So when we run this now, again, we should see an array that has, 0, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Yeah, okay. There's 11 stimulus intensities that we are passing there. So our stimulus, our model, okay, has 11 values to it, okay? 0, 10, 20, 30, 40, 50, 60, okay? Up to 100, okay? And our subject response rate also has 11 elements in it. What do they look like? Well, we can delete this out, okay? We don't need to see the length of it anymore, but let's just see, well, what have we made? So we'll just print sub response array. And what we should see is an array, okay, with 11 empty arrays in it. And so here we've got this here. Let me just make this a bit taller. Okay, here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here we go. We've created essentially an array of empty arrays, because eventually what we're going to do is we're going to put into this array here all of the trial experiments, or all the trial data for when that subject, okay, completed a stimulus intensity of 0 trial, okay? And then this array here will eventually be populated when the subject does all of the 10 intensity trials, okay? And so what we're doing is we're just creating a data structure that's a single thing, but contained inside it are all the responses for our experiment, okay? This is all we're going to do here. I hope that made sense. Like with a lot of programming, a lot of modeling things, there's not a correct way of doing it all the time. So if you think that you've got a better way of doing this, by all means, I really encourage you to run with it, okay? This is just one way of doing it, and I'm getting you to think about different ways of structuring data. In this case, this is an array of empty arrays, and in our next couple of videos, we're going to start to populate, or we're going to start passing values into each of these different arrays. All right, I'll leave this video here. I've been waffling on for long enough. It's 15 minutes or thereabouts, all right? All the best. Hope to see you in the next video. If not, good luck with your modeling career. All right, catch you later.